Hey everybody, this is Alex Merced from AlexMercedCoder.dev, and welcome to the next video in this Intro to Python course. And now we know how to do like if statements and loops and all that stuff. Now the next step is to kind of know how to bundle information together, because a lot of many types of things you'll do in programming require you to bundle information together, like a list of students, or a list of serial numbers, or a list of things. So understanding the different ways we can combine different pieces of information together um, and why you would use them is going to make life a lot easier. So I'm going to make a new Python file, collections.py, and we'll introduce them one by one. Generally, probably the one you'll use the most is going to be the list. In most other programming languages, you'll probably see this referred to as an array, like in JavaScript and Ruby. But here it's referred to as a list because it more accurately describes what's going on under the hood with a linked list. Not going to go there right now. But essentially what it is, it's literally like a list of items. So for example, if I wanted to kind of make a variable that represents my grocery list, what I can do is I can use these square brackets. These square brackets mean a new list, and then I can list more than one piece of information in them. So I can say, hey, I need to go buy eggs, comma, for a different piece of information, I need to get cheese and let's say cereal. Okay, so there's my grocery list. So it's literally like a list of things. Okay, and it's an ordered list, which means the order that I write them in matters. Okay, because let's say, like right now, if I go and I print this list, so if I can actually just print the whole grocery list, watch what happens when I run the code. So I type in Python collections.py, and see I get the list. But what if I only want to access eggs? So I want to say, hey, what's the first thing in the list? Well, what we do is we use this notation. So we put in the name of the full list, grocery list, and then we put square brackets, again, after it. And this allows us to specify what's called an index. Okay, so anytime you use a square bracket after the name of a variable, it allows you to specify an index, which is really just like which thing. So the index of the very first thing is always 0. Okay, so it's always 0 based indexing. You start from 0, then you go to 1, then 2. Has to do with the way things are stored in memory, and bottom line, the easiest way to think about it is it starts at 0. But if I run this now, see, the first print printed out the whole list, and then here I printed out one thing from the list. Okay, so that's pretty cool. That's neat. Yeah, so that's essentially how you access things inside of a list. Another cool usage of a list is to be able to you can do stuff like this. Like for example, I want to declare 3 variables. We'll say A, B, C equals grocery list. Now watch what happens. If I print A, print B, print C, eggs, cheese, and cereal. Okay, because basically what it does, it takes the first thing from the list and puts it in here, the next thing from the list and puts it in there, and the next thing from the list and puts it in there. Cool. So yeah, that's kind of how a list works. You can do some neat things with that. And lists also have a bunch of functions built into them. So if I type in like here grocery list dot, see these are all different functions that are built into a list. So I can use append to like add things onto it. Extend, if I remember right, that's for if you want to take 2 lists and put them together. So if I did if I watch it, we'll just do a couple different examples. Okay, so if I wanted to add milk to the grocery list, so I would do append milk, and then I can print the updated grocery list. And see that added milk. See, the first time it printed without milk, then it printed with milk. Now if I do extend, okay, extend, I'm pretty sure it takes a whole other array, so it would be like milk, butter, and what it's going to do is just going to take the 2 and make them one list. Okay, you see, it extended it with milk and butter. Okay, so it took that list and added it to the other list. Okay, other functions that are in there. Okay, I mean, we have pop. Pop just removes the very last thing from the list. Okay, So it'll reduce, it'll like, if I do it like this, it'll just automatically remove butter. So I should see that butter is gone. Okay. Oh, that did not quite do what I expected it to do. Let me think about that for a second. We printed out that, we printed out eggs, and it popped. Oh, yeah, that's right, because we just popped off cereal. Yep. Okay. And then, but the cool thing about pop is you could also specify an index. So let's say I want to get rid of cheese instead. I can sit here, cheese is at index 1, so I can say, hey, pop the thing at index 1. And see, now we got rid of cheese instead of cereal. Okay, nice and easy. So that's pop. Let's see what else we got in there. Dot. Append, remove. I think remove bases on the value. So if I said, hey, I want to remove, any instance of cheese, okay, it'll look through the list for the first time cheese pops up and removes it. And see, cheese is removed. So you see cheese is gone. Okay, so this cheese, and these are all referred to as methods. So basically the idea is that the list is the object, is an object, and it has a bunch of functions built into it, and these functions built into the object are called methods, just terminology. Okay, let's see what other methods lists have. We have sort. I'm not gonna go through exactly all of these. Pop, reverse. But you can see there's like a lot. Okay, count if you want to get the exact count of things that are in there. Copy if you want to make a copy, and so forth and so forth. Okay, but that pretty much sums up a list to keep things moving along. So I'm going to comment this out. Now the cool thing about a list is that you can add things and you can remove things. There's something else called a tuple. Okay, and the basic idea of a tuple is it works like a list except you can't change it. Okay, so if I wanted to create a tuple, so if I wanted to create a tuple of my grocery list, it would be like, well, let's say grocery list 2. Actually, I can just keep a grocery list. We'll just reassign it. I would use parentheses instead of square brackets. And then we say like eggs, cereal. Okay, and again, I can print it. And see, like notice that when I print it now it has a parentheses because it's a tuple. Okay, and let's see what kind of methods we have for a tuple. So if I type in grocery list now and say dot, see I can get the count of the tuple and I can get something at a particular index. That's pretty much it. Okay, so if I can go here, and then if I want to get something at a particular index, I can always just use the square brackets and say, give me the thing at 0. Okay, and I want to print that. So let's print that. Let's wrap it with a print. And see it works. The reason you would use a tuple is because you don't want the thing to change. And there are benefits under the hood to using a tuple as far as speed goes. So if you know you're not going to edit the thing, like you have a set of information and you want to just put it in a structure, that's because the underlying engine knows that this tuple will never change. You can allocate the memory a little bit better and it just all operates a little bit better. But you don't have all these other functions to manipulate the thing with because that requires you to have something that can change, like a list. Okay, so just to kind of point out the difference. But otherwise, they work the same way. Like this whole thing, what I could do, like the ABC equals grocery list, that still works here too. Okay, so that's the tuple. Then there's the set. Okay, this can't change and can't have duplicates. Okay, so again, we'll do a grocery list equals, in this case, you use square curly brackets, and it'd be like eggs, cereal, milk. Okay, so see, like this will work fine. So I print milk. I'm in grocery list. And see, you can tell it's a set because of the curly brackets. Now let's see if I try to put duplicates in there. So I put milk in there twice. See, it doesn't allow that second addition of milk. Okay, I can only put in the same value twice. So sets always have to have unique values, which is why sometimes, like as a trick, people will take a list, turn it into a set to remove out the duplicates. So just to kind of show you an example of that, let's just say like the end result equals, and let's say, hey, I have this list 1, 2, 3, 3, 3, 3, 3, 3. So I have duplicates there. So what I'll do to change it, what I'll do is I'll change this into a set. So I can use like the set constructor or the set function. That's going to change it to a set, but what I really want is a list. So then I wrap that as a list. So what's going to happen is that this converts the list to a set, which will remove any duplicates, and then I convert it back to a list. Okay, because again, you always operate from the inside out. So now, then we'll double check that this does what I said it does by printing out the result, print the end result, and see that's exactly what it did. It removed the extra theories. Okay, so those are ways you can kind of start seeing like how I can use these different types of structures. Now there's one more structure that works a little bit differently. Okay, all of these kind of really, at the end of the day, made like a list of items. The last one's called a dictionary. And what this does, it's key value pairs. Key value pairs. Okay, so generally the way I would use this is usually you use a dictionary to describe one single thing. So I might have item 1 equals, then what you do is you use curly brackets, and then there's always a key, which is a name of one variable in the dictionary. Kind of like how a dictionary has different terms, and then you look up that term and you find the definition of the term. Same idea here. So we're going to say the name of the item is called milk. And then you can do comma. See, so this is the key before the colon, and then after the colon is the value. So the key of name equals milk, and then we can say the price is 37. Very expensive milk. Okay, and then what I can do is if I want to access things inside the dictionary, I would say item 1 using the indexing little square brackets. I can then pass in the key that I'm looking for. So if I pass in item 1 name, okay, you see that gives me milk because the name of the item is milk. Okay, so typically what's going to happen is that you might have like now let's do grocery list again. Grocery list may be a list, but inside that list, we're generally going to have a lot of dictionaries. So a dictionary for each item, because first we'll have milk, which is, we'll just say 3.7, and then, we'll just keep making different items. We'll order cheese, which we'll say is $2, and then we'll also have cereal, which is $3. Okay, so see now, you're starting to see like how we can really start making our organization of our data interesting. So now, not only, I'm technically right now organizing 6 pieces of information. It's just that each two pieces of information describe one thing, and I have a list of things. Okay, and this is where it starts becoming important to like loop over items. Okay, so now I can like loop over this list and be like, for item in the name, and this works for all of the types of collections. In grocery list, so I'm saying and what this means is that it's going to loop through this list, and then on the first loop, this dictionary here is going to be item. And then on the next loop, this one will be item. And then on the next loop, this one will be item. Okay, so then I can, again, it's a code block, so I got to hit tab. And then I can print and say, okay, print out item name and item price. Because again, this item is going to have the dictionary inside. So I can then access the properties of that dictionary like I could any. So now if I run the code, see, it prints out all 3 items one by one. Okay, Very, very cool. Okay, very, very cool. Now, other ways you could do this, like let's say, um, yeah, that's pretty good for now. Okay, but I think, let me just try this out. Let's see here. Um, let's see what happens if I did A, B, because we have two things in here. So I think what's going to do, if I remember right, if I do this, since each item is a dictionary, again, it's going to kind of like, again, that whole like AB equals the list and it breaks it down. When it comes to a dictionary, what it does, it takes the keys. So my expectation is that if I do this, I should see like, it's just going to end up printing name and price 3 times. And that's exactly what it did, name and price. Okay, so what it did is it took the first 2 keys. So key 1, key 2. Okay, so then I could do something like, which that's not particularly helpful because you want to access the values. But just so you know that that's a thing that can be done. Okay, so typically I really would want it to be like item. And then we would just do like item, then the keys. Okay. Um, okay. Cool. Okay. And yeah, that's the basic idea of working with collections. You can loop through any of these. So like if I just had if I just wanted to loop through a dictionary, what I could do is do something like this. So we'll just, first save the dictionary in a variable, a dictionary, put the dictionary in there, and then I could be like for key of a dic, and then that's again not of, it's in. We use in Python. Oh, JavaScript habits. Okay, and then we can print the key. Now watch what happens. Okay, and you see like that last time it prints out the keys. Now if I wanted to get like the key and values, what I could do is I could do this function called dot um well, you could do dot values, but I don't want dot items. That's what we want. And what dot items does, it just turns each key value pair into a tuple. Okay, so essentially the first thing, and it'll become a list of tuples. The first tuple being sort of like, well, each thing will become an array of tuples. So essentially each tuple represents a key value pair. And just to kind of show you what I mean, let me actually just print out the result. So I'm just going to go over here, print the result of adic.items. But now what I can do is I can do kv, key value, and then print out the key value for each one. So you can see like here when we took the items of the dictionary, see it turned it into an array of tuples. So technically when I do this, kv, what I'm doing is I am looping through each key value. So here's the first key value, the name, milk, price 3.7. Okay, so see first it printed out name, milk, then price 3.7. Okay, so just so you can see like how you would loop over a dictionary, which you probably have to do a lot less often. I can't think of many situations where I'm purposely looping over a dictionary. There are times. I think probably more so in Python than when I do in JavaScript. But yeah, there's reasons you would want to do that. But again, these are the different ways you can store multiple pieces of information. And again, this is how you would loop over them, which gives you some new sort of powerful ways of working with things. So with that, I'll see you all in the next video. Have a great day. My name is Alex Merced from AlexMercedCoder.dev.